Hello, everybody, and welcome to part 4 of the Dynamics 365 Tech Talk Performance Testing Series. Today's topic, how to analyze and mitigate performance issues for finance and operations apps. My name is Janice. I'm going to be your moderator today. We are broadcasting this session through Teams Live event, and the audio can be heard through your device speakers. This session has been recorded on behalf of the Microsoft Corporation. When you join this event, your name, email address, and/or phone number may be viewable by other session participants in the attendee list. By joining, you are agreeing to this experience. The recording will be available on the Tech Talks Community Dynamics page within 5 business days. If you have questions for our presenters or need support, please use the Q&A panel located on the right-hand side of your screen. Our presenters will be responding to your questions during the event, and there will be time at the end for further questions. I'd like to thank you for your patience during those announcements. Now on to the main event. Presenting for us today from Microsoft, we have Senior R&D Solution Architect, Marcus Otta. So without any further delay, Marcus, welcome and thanks for joining us.
Thank you, Janice, for the introduction. Hello, welcome. Today's topic out of the Performance Testing Tech Talk series is Analyze and Mitigate Performance Issues for Finance and Operations Apps. My name is Marcus Otte, and with me today are my colleagues Davy Fliegen and Volker Deuss. If you have any question during this session, feel free to ask them straight away in the Q&A panel. We will answer them during the session, and as time allows, also recap during the Q&A towards the end of the session. Let's start with a small commercial for Dynamics 365 Implementation Guide. This book has been written by FastTech solution architects, and it provides prescriptive guidance for how to run a successful implementation of Dynamics 365. Related to the subject of today's Tech Talk is special attention to Chapter 17, a performing solution beyond infrastructure, and Chapter 14, testing strategy. The objectives of this Tech Talks today are: we will explain how to start analyzing performance testing result, help you starting analyzing common performance testing scenarios, and provide recommendation how to mitigate common performance issues. In today's session, we will not cover how to plan for performance testing. We also do not go into how to set up and execute performance tests, and we also do not cover any considerations for Dataverse and customer engagement apps today. As you might know, this is one of the sessions of a series of Tech Talks dedicated to performance testing. So earlier topics, how to plan for performance testing and how to set up and execute performance tests, have been made available already, and other Tech Talks on future topics will be added to the series in the future. Today's agenda: we start with explaining how to start analyzing performance test result, followed by analyzing common performance testing scenarios, and provide recommendations how to mitigate common performance issues. Finally, we will share additional resources. There will be time for additional Q&A at the end of the session, but please do not hold your question to the end. My colleagues in the background are eager to answer them during the session. Let's start with the first topic: analyze performance test results. Analysis of performance test result begin during test execution because it is important to collect data that will not be available at a later time, or it is very challenging to collect after the test execution, and the data will support later analysis if required. Also, collect the results according to the defined acceptance criteria to ensure you know if the test case execution is accepted or not accepted, and then the analysis must begin. Then focus on test cases that do not meet the acceptance criteria. They need to be analyzed deeply to understand where the most time is spent and improved with a fix and tested in the next iteration. Although during analysis you focus on the test cases that were not accepted, the test cases that meet the acceptance criteria should continue to be executed in future test runs as they contribute to the workload mix and create data that contributes to a more realistic data composition in the test execution. Finally, it is crucial to start early to analyze the test cases that do not meet the acceptance criteria to have improvements ready for next iterations. During the test execution, collect information. Later, you might not remember the specifics or they are not available anymore. This includes the condition of the environment in general before the test starts, and during the test execution, high-level performance metrics. Detect and identify obvious bottlenecks early, for instance blocking that harm the test case execution. Data volumes and data composition. Is any cleanup required already due to continuous test execution? For instance, batch job history, data management staging tables, user IDs and session IDs that have contributed to the test case execution, start and end times, including time zones for specific test cases, as well as the overall test run. Allow breaks between test runs to be able to clearly partition the load. This helps later analysis. Batch job and batch IDs for batch workload during test execution, as well as data management execution IDs for integration workload, for instance. Analysis of performance test result continues during test iterations. Ideally, you should only change one thing at a time for a given test case. Compare iterations of test cases and test runs. Are we on the right track? Are we getting closer to acceptance, or are we going into the wrong direction? Understand the trend and be open. What we mean by this is be open to new things and approaches and take a step back if necessary. Finally, focus on the analysis of test cases that do not meet acceptance criteria. What does analysis mean for manual testing executed? There are numerous tools and features that can be leveraged to collect and analyze performance. I just want to highlight a few of these tools. Some of those are also later used in the demos. And they are available to provide an impression. There are numerous reports and dashboards in LCS that can be used to monitor and troubleshoot performance. One built-in tool, the performance timer, while not to be used by the tester during the performance test, can be used to collect insights on slow interactions by a dedicated superuser during the test or afterwards for analysis. The reason for not enabling this for the tester during the test execution is the performance overhead caused by the tool itself. The feedback form can be used to help identify a specific session for later analysis. This is especially useful because with a busy system, there is simply too much information collected in the telemetry, so it is easy to lose track of what to focus on. And the query store collects amazing information that can be used to troubleshoot performance issues. If there is a specific slow process that requires a deeper analysis, users should collect traces so they can be analyzed further. What does analysis mean for automated testing executed? When you have executed load tests from automation, you can generate Excel reports from your result. This is available from either the test results window in Visual Studio or through the load test add-in within Excel. There are two types of reports that can be generated. The comparison report enables you to compare two specific runs with each other. In this report, you find that one of the runs will be treated as a baseline, and it shows you the progress or improvements comparing to the baseline. The trend report will allow you to monitor trends across multiple scenarios of load test runs. Both reports help you to understand if your test case execution is coming closer to defined acceptance criteria. In the next section, we will discuss how to analyze common performance testing scenarios using different toolsets. The first use case is general performance monitoring and slowness reported. However, you can also use this approach during the execution of a test run to observe the usage of the environment in general. In this demo, we will have a look at LCS monitoring, more specifically the SQL Insights and Live View, log in and access the application. In the LCS monitoring, the queries, the currently running queries, as well as the current blocking tree. Finally, we will also use the overall LCS monitoring overview. In the next couple of minutes, I would like to run a demo how to troubleshoot a real problem of live performance using the Lifecycle Services tools available in LCS for Finance and Operations app. Imagine a group of users report severe performance problems in your application. Hopefully you know the environment, but you do not exactly know when the problem started. So let's try to analyze this. First, I would recommend to open the monitoring page of the specific environment. It starts with the overview page. I recommend to go directly into the SQL Insights and here on the Live View and hit refresh or load data. It takes a couple of seconds. It will populate the information with the currently executing statements as well as any blocking statements if there are. In this environment, there are no blocking statements, but currently executing statements is populated. I would recommend to refresh a couple of times to see whether the session ID changes here and how the total elapsed times visible in the overview evolves and what the queries are and whether they are changing. In my sample here, the sessions themselves, the executing statements are progressing. Sometimes they are changing. They all work on the number sequence list, and we also saw general ledger tables in the list with the queries. Of course, it's a little bit tricky to, let's say, make screenshots of this visualization here. The next step I would probably do is try to actually log on to the environment and see if you are able to log on and let's say open the application and whether the application itself responds quickly. And based on the load times of the form, the application itself seems to operate responsive. The users will be able to log on the environment and work in some areas, but probably busy operations that we saw in the live view, they cause trouble in some areas. Now, I would love to have a little bit of a history of queries that have been executed. And also we see some blocking statements here and there. If we now move to the queries area, and then select the currently running queries and just execute this one. It takes a couple of seconds to populate the data. So what I would recommend is just export a series of those currently running queries to Excel for later investigation. This query here looks pretty similar to the one we had already. I will export this as well. Let's move to the next topics. We also saw currently blocking statement. Let's have a look at the current blocking tree. Blocking SQL statements are appearing and disappearing as the system is progressing. Currently, there is no major blocking visible. The next one, what I would recommend is if you start the overview page from the very first beginning, let's use this one here, and then it pre-populates the current date, and you can modify the period where you want to go backwards. So let's use 1 hour and then hit submit time. In a second, you will be able to see the overall activities in terms of user load, activity load on the environment. Sometimes takes a little bit longer to load. I will just wait for a couple of seconds. Now, as you can see, a couple of minutes ago, the SQL Server really started to get large utilization. So it seems to be that the SQL Server itself is busy and the activities are still progressing. So everything is kind of okay, but you also see that there is only very few interactive load. The most load is created from the batch activities back to SQL. So SQL utilization is currently relatively high. This is the max SQL utilization. If we go back to the application itself, and just trying to see whether the application still responds. So although we have a relatively high SQL utilization, the application itself is still responsive. Even if I go to general journals, filter on posted, the information is populated pretty quickly. Although the SQL utilization is currently high, the system is still responsive to my requests. So for this use case, the conclusion was the system is busy, but still responds to most requests. If this is an issue for the other test cases in the mixed workload, then the recommendation would be to reduce the batch workload with less parallelism to allow more SQL capacity for the remaining queries and activities. So now let's have a look at the scenario a specific user action is not performing. We will use the feedback functionality to collect the session ID and browser session, use the performance timer to understand whether time is spent on the server or on the client, look into LCS monitoring activity raw logs, all events for browser session, pick an expensive activity ID, and look into the raw logs for this specific activity ID. In the next couple of minutes, I would like to run a demo how to troubleshoot a performance problem of user activity using the lifecycle services tools available in LCS for Finance and Operations app. Imagine a group of users report performance problems in the application during a specific activity like creating a sales order. So let's analyze this scenario. First step would be to use the feedback to collect the session ID from the user executing the test. So if the user uses the help area, then the feedback, you can see here the session information, which is the browser session ID in this section here, as well as the user ID in this section here. So this is the context in which the user currently working on the session. This data is very useful to be collected for later inspection and reusage. So I make a note of it. Press cancel here because I don't want to provide feedback. The next opportunity for the user is actually to use the performance timer visualization within the application by adding the @debug equals develop to the URL of the system and just doing his tests while browsing around in the application. Just be aware this additional functionality adds a little bit of overhead to the client session. So the activities now in the browser are a little bit slower than they used to be without the performance timer enabled. So if I open the All Sales Order tab, you see that in the upper right corner, there is an area where times are accumulated and visualized. If I open this one here, then you can see the different activities that has been executed in the browser session, as well as the overall time spent here. And if I click on any of those activities, then you see how many of the time is spent in the client versus in the browser interaction. So this performance timer is good to analyze where the most time is spent. It's either on the server side or on the client side. Assuming that the most time is spent on the server side, now we will use the browser session information and look into the LCS monitoring. Just be aware the LCS monitoring takes a couple of minutes until the data is actually transferred from the tier 2 environment into the LCS monitoring. So there is a small delay of a couple of minutes until the data is visualized here. If we start on the environment monitoring overview tab, then in the lower area, you see the user load with the user activity IDs. You might remember my user ID here, as well as the activity load, split it in all the controls and the forms that have been used while the user is browsing or executing the application. Also in the user activity down here, you see the user sessions as well as the specific activities IDs below the user session where all the monitoring information is as well visualized here. Of course, it's not very handy to browse around in this visualization here, so I will use a different approach for analyzing what have happened. I will actually go to the activity. Within the activity raw logs, there is an all events for browser session. So I will use this one here. I will find my original browser session ID, which I used to run through the scenario. Then it's also worth to filter on a shorter time frame that makes the output a little bit faster. I will also extend the row limit here and then press search. That usually takes a couple of seconds. Once the data is visualized, I usually export this immediately to the grid, open the file, then you can use the raw data to insert a table. Use the long duration values to summarize the overall duration, and then use either the activity ID or the task name to see on which activities the most time is spent, or on which task name the most time is spent here. So as you can see from here, a lot of time is spent on wait for inbound interaction, while the application itself wasn't really that slow, so to speak. But if you see a lot of duration here, you sometimes see slow queries also reported in that context, and then you can start the investigation from there. If we remove the task name for a second and take the activity ID, and then we sort the results by some duration descending, and then you can see in which activity ID the most time has been spent in this browser session ID. So we can make a note of this activity ID. And in the second step in LCS, so going back to LCS, then we use the query all events for activity and use this activity ID. Search the details for this activity only. Once the data is visible, directly export to grid again. Open the file. Now you have similar data just for this activity ID. And use the same pattern that I used. So create a pivot table. Use duration in milliseconds. And this time I take the task name as row. And again, I sort largest to smallest. In this activity ID, it seems that the most time is spent on actually the HTTP request end activity. So, and it doesn't really contain any SQL. So I'm, for instance, using this mechanism here to search for SQL details, but I just see AOS SQL connection info and session info. So not really a slow SQL statement, for instance, has been reported. So the activities within that browser session ID as well as activity ID seems to be all driven by the application. So that was just one flow of analyzing possibilities where we started a browser session within the application, then looked up the specific activities IDs visualized in LCS monitoring. So the conclusion in this case was we did not find enough details in the telemetry yet, let the user create a small video to demo the problem and create a trace and analyze this by using the trace parser, which is the required next activity to get into the details. In the next demo, let's have a look at the scenario a specific batch job or task is not performing. We will use the batch job history, the batch history table, to look the start and end times and the AOS instance name of the batch execution, then look into LCS monitoring, activity, raw logs, all logs, and use the search term batch task ID. Pick the activity ID for the execution of the batch task and look into the raw logs, all events for that activity ID. In the next couple of minutes, I would like to run a demo how to troubleshoot a performance problem for batch activity using the lifecycle services tools available in LCS for finance and operation apps. Imagine a batch job execution is becoming slower compared to earlier executions before. So let's analyze this scenario. First, you start with the batch jobs. Identify the batch job you are interested in. Look at the batch job history and view the task. So this is the history of task execution in the context of this batch job. You can also use the menu item batch history by directly modifying the URL and adding the menu item batch history while accessing your application to look at the data directly and then filter from this menu item directly. This is a batch job that posts general ledger journals and then create subtask, runtime task to be executed in parallel with parallel posting on general journals. From this overview, you take the reference, which is the batch task execution ID, as well as the server name and the start time of the process and the potential end time of the entire process here, which is around 8:44. The next step or view would be within LCS. The environment monitoring overview tab, I already started from the end of the batch job and looked up the last 60 minutes before, and I see the SQL Server is pretty busy. At a certain point in time, the SQL activity is dropping then again. So this is just to get an overview. There you also see a lot of batch tasks here on various batch servers. You might remember we made a note of the batch ID. The next one would be then on the activity tab in the monitoring page, take the all logs, filter for the right time, and take the reference ID that we earlier copied and press search to open that information. You basically here see the activities in the context of this batch task ID. With in the info message, you see, okay, this batch task is creating a number of subtasks, and then the subtasks are actually started with invoking the batch runnable activity ID with the ID that I just filtered on. So for the details of this posting activity here, I take this activity ID and then go in another iteration of the monitoring tab to the activity, search for the query all events for activity ID and paste the activity ID, modify the row limits and press search again. It takes a couple of seconds until the data is populated. Then export the grid Open the file. Use the same mechanism that I used before. Insert a pivot table to visualize a little bit the content, and then search for a term second to get the execution time in seconds, for instance, as a measurement for the overall runtime. Then you can also search for the batch task ID, for instance, to just visualize that these are the queries that are executed in the context of the batch task ID that I filtered for. And now I'm searching for the term statement and move the statement to the rows. So that means that in the context of this batch execution here, these are the queries that have been executed and reported in the telemetry as slow queries. And this is the overall runtime on the queries that has been executed. And here you can relatively easily track down the query that is taking the most time in this context execution of the batch job. So in this case, the conclusion was that there was a couple of slow queries reported in the activity ID that requires deeper analysis by using the query store. Let's now take a look at the tools available for troubleshooting and where they can be used. More details you can also find in the Tech Talk link in the upper right corner. Tier 2 Plus environments is the sandbox that we initially use for testing. As mentioned in the first Tech Talk of this series, volume performance testing should be executed on Tier 4 or Tier 5 environments. We focus on exceptions. LCS monitoring is not available for Tier 1 since the telemetry is not collected for this type of environments. The query store requires SQL database access, which is not available for production environments, but you can use it with the just-in-time database access requests to access the database and query store for Tier 2 Plus environments. And this is very handy to analyze the SQL details like execution plans. The Windows performance monitoring requires operating access, which is only available for Tier 1 environments. Performance SDK requires system access that is not available for production environments. Other third-party tools, examples like PSPing, Fiddler, they have all their valid use cases, but we will not discuss them in detail in this Tech Talk here. So far in this Tech Talk, we have covered all important aspects to consider when analyzing performance. Now let's have a look at the common mitigations. And this may come as a surprise. Mitigation starts with design, and here in particular for scalability and concurrency. When we design a solution, we always need to keep scalability in mind to be able to reach the expected throughput. With design for parallelism, for instance, we see performance goals like, can you post so many general journal lines in 1 hour? Can you invoice so many sales orders in this time frame? How can we scale? One answer to this is parallel processing. Then build lightweight components. Ensure a component is lightweight, not a large component with large footprint or long blocking, to ensure it does not consume large amounts of resources like memory, CPU, I/O. Design with optimistic concurrency control in mind. For example, the system internal process of number sequences. You need to get a sales order in the beginning because of other documents are going to depend on this number as a foreign key. The current design of number sequence for non-continuous number sequences, a second connection is opened, and once the number was received, we immediately commit that connection to allow other processes to get the next number afterwards. Consider alternate storage technologies as appropriate. Common data service, data lake, blob storage have all their valid use cases. Not all data should be stored in the OLTP transactional database. Design a sound data model. Data model and normalization is important, but there are also valid use cases for redundancy in the data. And for an overall and indexes, the common use cases need to be part of the design. Design shorter transaction. It helps to reduce lock contention, increase user concurrency. It also matters when you create a lock. For example, the internal process of invent sum for sales order confirmation, and while another user is posting a purchase order on the same item dimension, we need to increase the concurrency. The system touches invent sum delta first, then the last commit comes in, the TTS commit notify event is fired, checks whether the invent sum is available for the current session. If yes, then we apply the changes to the invent sum table. With this way, we hold the invent sum table lock shorter compared to when we would touch the invent sum immediately within every process. Design for scalability is not a one-time operation. It is a continuous process if the application usage grows. Design for responsiveness. Take advantage of set-based operation. It is the power of a relational database, reduces round trips, can improve performance by orders of magnitude, depends on what you do with row-by-row operations. For instance, process 1 million records. For each of the records, you do 10 different checks equal to 10 million operations, versus a handful set-based operation on the entire set if you would use set-based operation. Consider online versus batch processing. For instance, provide user with a choice to pick online versus batch based on the size of the document. When a user knows the option is there, they would pick the right choice. Simplify the design. Overly complicated design, overly normalized design can pose performance challenges. A practical learning from ourselves. Ambitious design with DB database normalization supports model purity, but the framework need to do a lot of magic to implement this. So in the core data model, we also denormalize the part again in later releases to increase the performance. Take the DB size and growth into account. When designing a solution, consider how much data must be brought into the system prior go live and how much data size will increase over time. When DB grow rapidly, performance will most likely drop. A lot of tuning is needed to keep the solution at the same response rate. Design with aggressive caching. Caching is storing the state of previous done work, so we do not need to perform the same work again. There are different kinds of caching techniques available for Dynamics 365, and they serve many purposes. Use tempdb diligently. When you use the tempdb's right, you can achieve many of the blocks mentioned on this slide, like simplify the design, use set-based operation. But please do not overuse temp tables. Consider asynchronous processing. When there is work that could be performed in parallel without holding the user waiting, use asynchronous processing. Use OData when appropriate. We see a lot of misuse of OData leading to critical performance issues and some unsatisfied Dynamics 365 users. This is also the reason why we introduced service protection limits and priority-based throttling. Many additional mitigations are recommended that can prevent performance from occurring during the performance test, or even more frustrating, before go live. During go live. More details you can also find in the Tech Talk linked in the upper right corner of this slide. Please be aware, with every performance problem solved, the wealth of experience for your solution will also grow. Please also keep in mind the tuning process is an iterative process. In the first step, you focus on the first visible bottleneck, narrow it down by finding out where you lose the most time and focus the effort there to optimize. Troubleshoot the issue, implement a mitigation, test it out in isolation, deploy and test it during the test run. Once this problem is solved, then focus on the next bottleneck. On the next slide, we will have a couple of resources to share about the tools that we used during this tech talk. For instance, a couple of links on the lifecycle services, performance timer, query store, as well as traces and trace parser. This concludes today's session on analyze and mitigate performance issues for finance and operation apps. I want to invite you all to revisit the recording for the other tech talks and to stay tuned on future tech talks in the series of performance testing. Over to Davey. Are there questions from the Q&A you want to highlight and discuss?
Yes, thank you, Marcus. I think that we had a bit more questions than we had in the earlier session today. So I will just summarize some of them. So there were questions on how to access the query store in a tier 2 environment. That has been answered also by you later in the presentation regarding to have the JIT access and then the allow listing, and the docs article has been shared. There were questions about there was an important question, I think, about what is a responsive page. I mean, here it's absolutely critical, and also refer back to Tech Talk 1 on planning for performance, that upfront, together with the business, with the customer, you discuss the performance goals. They should be documented, and there should be also sign-off post performance testing and prior to go live, because otherwise it becomes a really subjective discussion, and it could lead, and it will lead then a lot of times to escalations post go live. So we need to come to, these figures has to come from the business, and they have to be documented and sign off. There were some issues with tools or LCS tools not being available at the time that you need them. If you face any of these issues, please log a support ticket. It shouldn't be like this. And I also want to highlight the question on the retention time for the telemetry data to be available, which is 4 weeks for production environments, but for sandbox environments, it's only 2 weeks. So that's why it's important what Marcus mentioned. Some of the information you should collect during the performance testing execution, and some of the information, telemetry information, you should analyze as well within certain weeks after, correct? So it will not be there forever. Also related to query store, there was a question, yeah, if we refresh an environment, then query store is lost or some of the data is lost. How long should we have data collected before we have reliable information in query store? It goes actually in two ways, correct? So if you have a production issue and you would restore the production database in the sandbox, it also restores the query store and you have all this interesting information available. And the same if you would start from scratch and you do perf testing in a sandbox or a perf test environment, you also build up data, correct? So between iterations, as long you will not completely restore the environment. And then there was also a question regarding API available for environment monitoring. Here I pasted a link, and this link is also in the end of the presentation, how to get data easy to analyze in Azure Data Explorer, and that we're also working on in Link and with operational insights to get telemetry data appearing in there. That was the summary I had until the last couple of minutes, so I don't know if there are any new questions came in.
I don't see a new question in the Q&A panel.
So then I think I covered more. Yeah, one more thing about throttling and all data. So if you're facing any throttling, that should be, of course, be investigated. At the moment, there's only resource-based throttling live, but we are about to publish updated articles for usage-based throttling. There's no defined timeline yet, but this will also be released most likely during October release later this year. And we should be aware that also service protection limits for all data, similar than for Dataverse, will be applicable for finance and operations.
And on the LCS raw logs, activity raw logs view, where I used a lot of the queries in today's session, I believe the last one is the throttled event. So that gives you the possibility to analyze whether on your current testing or production environments you already suffer from throttling.
Exactly. So I think that if there are no more questions, I would really like to thank you for today, and thank you, Marcus, for the great presentation. I want to give back the word then to Janice. Janice, back to you.
All right, thank you. All right, everyone, I'd like to bring your attention to a link that I posted in the Q&A panel. That is a link to a short survey for this web conference. We ask that you please take a moment before logging out to access it. Specifically, if you would like to see more demos during these sessions, please include what you would like to see in your answer to question 6 of the survey. As a reminder, the recording for today's session will be available on the Tech Talks Community Dynamics page within 5 business days. I'd like to extend a big thank you to all of our presenters, and thank you, audience, for logging in and joining us today.